right, Scott, I want to welcome you to the show today.
Thank you. Nice to be here. Really appreciate it.
Well, we did a little prep call a couple weeks ago, and it was actually more than a couple weeks ago. Before we were going to talk about disruption in the manufacturing industry, which
Well, disruption has arrived.
we hadn't really prepped for this at all. In fact, I know I had talked to Jay, who obviously you and I both know is one of the big investors in Paperless Parts, and he said, I'm not really sure I'm going to travel. I think something's happening in China that's making me nervous. And this is like, I mean, the news was super small at that point, but
Yeah.
now we're talking about disruption at scale. But let's talk about manufacturing, and let's talk about disruption that's happening right now. And like, I'm going to ask a question like, what? Well, first of all, tell everybody who you are and
Okay.
a little about your business and your industry.
Yeah. So I started a company called Paperless Parts 3 years ago with some really great manufacturing people. I'm the CTO there, and essentially what our mission is to get people access to manufacturing, right? Be that interface between people designing great new stuff and people manufacturing that great new stuff. Lots of challenges in that space. The world's changing, and we are trying to keep up with, how quickly product designers want to move versus, how hard it is to manufacture stuff.
So you're the intersection between the designers of what is wanted and
Hmm.
by the consumer and the manufacturer that can actually get it out the door. You sit in the middle.
Exactly. We help those manufacturers figure out how they're going to create a new part or product and quote it, because that is a key piece here, and automatically identify what challenges they're going to face when trying to produce it, and be able to communicate that back to the product designer in a way that makes sense.
So let's talk about the problem we have with the corona, with the plague, with the pandemic that we have going on. What is, from a manufacturing perspective, can you get into some of the mechanics around why is it so challenging to make a mask for this to
Yeah.
prevent this?
Well, so what's happening, because so many people are getting sick, there's this huge increase in demand for a very specific set of things: masks, ventilators, things of that nature. These are not, and these are things that are really hard to just make in your basement or garage. And since the demand has shot up, there's so many people who want to help, who want to make this stuff. People are sewing masks. People are trying to come up with garage ventilator designs, and it's fantastic. It's great to see everyone trying to help. But certainly there are realistic issues with, with how hard these things are to make. And, to think about that a little bit, if you have a garage ventilator, typically when you make a medical device, that is years of development go into it, years of engineering and research and testing. And then there's these strict processes that, you have to verify these designs before they make it into operation. And we can remove a lot, the red tape aspects of it, but we still need to make sure, if you deliver some new ventilator design into an ICU, you have to be fairly confident that it's going to help more people than it's going to hurt, right? I'm not an expert on ventilators, but, they move air, they're pumping air, right? If you pump the wrong amount of air, you could kill someone. If you do nothing, you could kill someone as well. But you certainly need to make sure these devices are safe, and it's not super trivial to design and build a ventilator. So, but an easier example is masks. So you see lots of people trying to,
Scott,
sewing
can
masks.
you just adjust your camera down a little bit?
Oh yeah.
Cool, perfect.
We have lots of people, sewing masks at home, for example, and that's great. And I think there's going to be a use for a lot of those masks, although it might not be doctors in hospitals or patients in hospitals, because what people are always talking about is you need to have these N95 masks, right? And the key there is you can breathe through them, but they actually stop the virus, and that's a really challenging thing to make. A cotton piece of fabric isn't going to do that, and why is that? Let's talk about how big these things are.
Yeah.
So viruses are really, really small. The coronavirus is, and I just looked this up, it's 125 nanometers. That's the diameter. It's like a spherical shape.
Okay.
So 125 nanometers, that's very small. People are talking about 3D printing masks. The smallest printable feature. So if you're trying to make something with a hole in it, the smallest you could really conceivably 3D print would be about 0.5 millimeter, 0.5 millimeters.
Okay.
That's 4,000 times bigger than a coronavirus particle.
So when they say that South Korea somebody's invented a 3D printed mask, it really is not going to be sufficient for blocking.
There's stuff we can do with 3D printers. We can print maybe some sort of mechanism that holds the filter fabric in place, or we can make face shields. Like there's a lot we can do with 3D printing, but we're not going to print, a filter paper with the right, size holes in it. Again, to let air through, but not viruses. Now, people can produce stuff like that. So when we think about relative sizes, so that you can 3D print things thousands of times larger than a virus, but we can manufacture in general things much smaller than a virus, which is pretty cool. So current state-of-the-art electronics processes, the kinds of things, Intel would use to make a computer chip, they're down at 5 nanometers. They're making transistors that are about 5 nanometers. So several times smaller than a virus particle. So it can be done.
So general manufacturing. So you're saying, okay, we have this class of manufacturing that's been hot for 3D printing. And then we have kind of general traditional manufacturing of electronics equipment, sort of a traditional manner. We can get down super small there. Is there anything in between 3D printing and full traditional manufacturing? Is there you had mentioned CNC. Is that a different type of manufacturing that slots in the middle?
Well, you can do different stuff with CNC. A lot of this will come down to, just the right materials exist. Like, can you find a material that maybe is natural or is easily made through, I guess my point is we're not going to be cutting holes of this size.
Yeah, right.
But we may be able to find some materials that work.
So the disruption, we talked about speed before, Scott, and we talked about being able to, in the general challenges, producing, and this is an example we'll use with the pandemic, but it could be anything. Companies want to move fast, and now we just want to move faster than ever. But we now have to scale production, and so we have the desire for these something smaller than 125 nanometers to prevent the virus, this mask type of thing, and then we have the manufacturers that have the ability to do, let's say, 10,000 a week, to produce 10,000 a week, and now they got to go to 50 or 100,000 a week. When someone says I got to go fast, and then it's got to be redesigned, like where do you slot into that, and then how do we make that happen? Because it seems like the equipment has to change, plus the design specs have to change, and then you've got to marry those two together. And so how do you envision that happening?
Well, there's this whole other class of manufacturing. When we think of manufacturing, there's kind of the cheap plastic stuff that's often outsourced. That's really high volumes, typically low tech or low skilled, maybe labor or machinery being involved, very commoditized stuff. Then there's electronics, making computer chips. It's high volume. You're making a lot of those, but it's also really highly automated, super proprietary processes, not the kind of thing you can stand up in a garage. But then, and this is a lot of what happens in the US for manufacturing, there's stuff like aerospace, planes, rockets, machinery, right? And a lot of what we do here is we build machinery. And, if you talk about scaling up from making 10,000 units to 10 or 100 times that, it's really about automation. Can I, do some step that maybe used to be manual or used to take a certain amount of time, and that's okay at your normal volumes. Well, now you need to scale up. Okay, well, you need to automate it. So some combination of, building a custom machine, doing robotics, or, applying robotics to it, making something smarter and faster. That's where I think a lot of folks can really help and play in this area. You can start designing that machinery, iterating on it really quickly, and that's where stuff like CNC machining and 3D printing can really help out. So machine shops in the US would love to help. They're not going to, cut a mask out of a piece of metal. That's just not the way they're going to help, but they could very well create,
the machinery.
Yeah, the machinery that does it. And there's other things, we're working with a company, they are 3D printing ventilator splitters,
Okay.
so essentially tubing, like a valve that will let more than one person share a ventilator. I'm sure there's all sorts of medical questions to be answered there, but still they're able to produce really quickly the mechanisms that may make that work.
Tim Ferriss had he released, that's a trick they were using in Italy, because they were having, and this is happening in New York right now, there's, 100 people in the hallway dying because they can't get them on a ventilator. But if they split that ventilator into 4 or 5, and there's rudimentary ways to split, but I can see if someone was, manufacturing a part that had a 5-way split.
Right. Nice secure split. You can plug tubes in, whatever it is, right? That's the sort of thing that, we can turn those around real quick. And in a matter of a few days, they designed and printed hundreds of these things.
Yeah.
And they can print thousands, you can make those really quickly.
And that technically would be like a plastic splitter of some sort, was maybe a coupling or something like that.
That's right? Exactly what it is. They designed the coupler so it did what it had to do. It connected tightly and had the right airflow properties, and there you go. Now you can produce them.
Okay, and that would be like a classic 3D printing type of a model that could be put together, and you could do that at scale. I see how that would fit.
Yeah. Absolutely.
So your point, and I think this is worth exploring, is that we're going to need machines to create these the traditional machines create the traditional volumes. So to create the exponential volumes, you're going to need to do things in a little bit different way, like Henry Ford with his production produced X amount of Model Ts, color painted black. Now he's got to put out an exponential amount. He had to come up with a new way. And if you could have the machine shops, an exponential, I'm using that word, but let's say it's 100 or 500 machine shops, basically they knew this, they could iterate on a spec, and you guys would sit in the middle with the tools that they could submit designs to, and then the manufacturers could pull those design options out, and then essentially they could build their equipment from that. And
that's the idea. And where a lot of that comes down is it's different skill sets. So you have, typically the people designing machinery, these are mechanical engineers. They're working in what you call a CAD tool, computer aided design. And they're designing the 3D geometry or the 3D shapes that are going to become, for example, a splitter, or some sort of coupling, or some metal piece of equipment in what's going to become a giant mass production machine. And they're typically experts in the domain of the problem they're trying to solve. So maybe this one mechanical engineer is an airflow expert and knows a little bit about medical devices and can understand how to make a coupler that splits things. Sure. But they might not be experts in this new manufacturing technology. Meaning what's the capabilities of current state-of-the-art 3D printers, and if it's something carved out of metal, subtractive manufactured out of metal, what's the current capabilities of a CNC machine? So they're going to design a thing, and they're going to send it over to a manufacturer, and the manufacturer is going to need to figure out whether that can actually be made on their equipment. So that's where Paperless Parts comes in, is we will analyze the, there's a lot of aspects to it, but essentially we'll analyze the design, and we'll apply that shop's particular capabilities to it, and we'll look at their design rules, and design rules tends to mean things like, if you're like injection molding something, there need to be certain draft angles on walls of the thing you're making out of plastic. Or if you're CNC cutting, there's limits on how tight a radius can be on a corner. Things like that. Analyzing the design for those little details and how this thing can be produced. And to be able to deliver that feedback instantly or nearly instantly, to be able to say, hey, we can make this, but we can't hit this radius on this corner. Is that okay? Or even what's more useful, it's not usually a yes or no. It's usually, hey, we can make this as you've designed it, but we could make this a week quicker and at much lower cost if you go back and change this or increase the radius here or move this hole a little bit further away from this edge. It's just a heck of a lot easier to make. So that's where the iteration comes in. That's where you're really seeing collaboration between the designers and the manufacturers.
Yeah.
And I think 50 years ago, a mechanical engineer would have fully understood manufacturing processes.
Yeah.
But that's moving so quickly. If you specialize in designing stuff and in your application domain, meaning medical devices or machinery, you are probably not up to speed on what the latest 5-axis CNC machine is capable of, or 3D printing especially, because that moves real fast.
Now, why wouldn't they just send that design directly to the manufacturing company and bypass you? Like are you providing that interface? Because
we are the interface. We are the communication tool. So effectively,
you're doing the translation basically. So the shop sends it in, and it might go out to 4 different manufacturers. It doesn't have to go to one manufacturer, right? They could go to multiple manufacturers in theory, right?
Yeah, absolutely. But let's just talk about, let's say you want to communicate to someone that, say it's a fairly complicated part, lots of different faces and edges, holes, things like that. If you want to make the point that this particular corner needs, there's a radius here that is driving cost or extending lead time, and I want to communicate to you that that's the thing you need to look at. How would you do that today? So let's say the mechanical engineer is using SolidWorks. That's a really popular CAD tool, and they've designed it. They've sort of exported their design into some universal file format, and now it pops over to the manufacturer. Maybe they have a different CAD tool, maybe a cheaper one or just a different one for whatever reason. So they're looking at it, they're trying to analyze it. First of all, they typically don't have tools that will automatically identify what these manufacturability issues even are. So it's a human trying to look at as much of this part as possible to figure out if there's any catches or gotchas in it. And then how do they communicate that back? So maybe they take a screenshot, drop it into an email. There are ways to do it, but it's really clunky and kind of intensive. So what we've created is a collaboration tool in the context of this geometry. So I am commenting right on the design, and it's a real-time collaboration between the two sides.
So it also brings, I can see, and back to the problem in the story we're trying to solve for is in a disruptive time, we want to have speed of iteration to respond to the market or respond to the external condition, which of course is the corona right now. So this was what this collaboration tool gives two disparate parties speed ultimately to build.
Absolutely. Yeah. Okay. And it's all collected in the same place. And I mean, that's a problem you run into in manufacturing where if you iterate on the design 10 times, and then you say, okay, let's go, let's build this thing. You might get the wrong revision produced. That happens more often than you would expect.
It might be a slant at 4 millimeters versus 0.02 millimeter. Okay.
Yeah, managing this data is not trivial, especially and most of the time the two companies are using different tools, and that interface is really tricky.
So in theory, this could be really good because you can have a lot of these job shops that have a lot of subject matter expertise in their domain. They have the ability now to scale communication to multiple different parties where they won't necessarily have that because they're just a small job shop out of Wisconsin that's really tightly focused, but it's harder for them to get their message out to the broader community in getting their people employed and solving problems.
Well, and typically, I mean, the supply chain runs deep. So it's all of that. And then it's also, so I'm a job shop and we need to work through these design issues so that this becomes, kind of easy to manufacture quickly and at a reasonable cost. But typically they have to go source material for it. So stock material to make the parts out of, and then often we call it finishes, right? So maybe this has to be plated in a certain way, especially if it's a medical device, so that starts to really matter, getting the right material and then finishing. So maybe I have to mask it, meaning just like if you were painting, you might need to do some sort of coating to make it have the right material properties, and you have to mask certain places on it. So it's not just the if you're the designer and you're interfacing with the job shop, that's almost like the general contractor, to use an analogy to the home, right? But that general contractor is going to farm out certain pieces of that work to other specialists.
Okay.
And they need to communicate all that same stuff to their specialists. So this keeps that thread of the design and all the information that's needed to manufacture this part. It keeps it all together and really reduces the risk of something going wrong.
You could, I'm not as familiar with all the wording, but let's say they're designing a medical device that's producing medical equipment at scale.
Mm-hmm.
You're saying the outside part of that machine might have to have a certain zinc alloy finish.
Right on.
But that might be another third party, and that job shop might take that request down and store that little file locally, but it loses the context of the whole bigger program, the whole bigger plan. And so you have these infinite complications within the design. You're keeping it tight so that people can iterate on the same design without losing the efficacy of that whole process.
Yeah, and as part of that manufacturability feedback, if I'm trying to communicate to the designer, how they can change it to make it more useful. So, okay, let's get real on an example. We CNC stuff out of aluminum a lot because it's a light metal. It's really easy to cut it.
Okay.
Effectively, CNC machines are basically computer-controlled drill bits that are cutting holes in metal and carving this part out of a block of metal. So aluminum's a really cost-effective material to use to make custom stuff out of metal. But it's got some undesirable properties. It's more likely to corrode than, say, stainless steel, which is much heavier, much more expensive. So typically you plate aluminum. Basically you're sending it out. It's going into these vats of chemicals and getting plated so that it has better corrosive properties, or is less corrosive. So depending on the details of how that needs to be plated, that might be a key piece of information before finalizing the design to go to the plating expert and get their feedback on the design. And if you need certain types of, so now to speak to medical, right? So a lot of times, say you're 3D printing something out of plastic, but it's for a medical application. There's really specialized plastics you might use for that, specialized polymers. Who knows what the availability of those things are right now? Sure. So even the company that's the expert at 3D printing, needs input from their suppliers to know what the lead time or cost might be on a particular component they're being asked to quote. So just being able to get all that input from all those different sources, that plays a huge role in being able to iterate quickly on these designs.
And so are you, as the Paperless Parts, coordinating with those suppliers, or is it really just holding the design specs together such that there's a singular place to be able to share out specs to once those suppliers have been
it's absolutely helping coordinate all that communication. Yeah. So it's analyzing the geometry, it's identifying what kind of material might be needed to produce it. It is checking whether that's just available off the shelf from various sources, and when it's not, it's helping you send the information needed to a material distributor to get a quote. Yeah. It's doing the same thing on the finishing side. And, people aren't super concerned about the security of ventilator designs maybe, but in general, in sort of normal operating environment, in normal economic conditions, the intellectual property of a design is really, really important to protect. So if I'm designing this new product that's going to hit the market, I'm concerned if the job shop I'm working with is sending that out to a huge number of potential subcontractors to get quotes on it.
I mean, there's a reason. There is one of the reasons why China was able to accelerate early on is because of the theft of intellectual property.
Absolutely.
There's a reason why the Chinese jet fighters, look very similar to the fighters, and so I think it is this importance of security and intellectual property theft is a big one, and the job shop owners identify security in the business, and they need to trust that the third parties that they're working with, it's not going to disrupt their potential business because someone stole the design in Thailand.
No, and that's exactly it, or stole the design from maybe the end of the supply chain where people aren't as on guard about this stuff. You think about, so to talk about a fighter jet, right? Those acquisitions start at the military level, then they go to these big prime contractor, these big defense contractors, and then it just gets farmed down further and further down the supply chain. So a certain subassembly goes to a job shop, which then farms out where they're going to get the material and the hardware and the finishing and all this stuff, all the way down to some garage somewhere that's painting it, navy blue.
Sure.
And they have the right paint and they know how to do that. But they need the drawings, basically the specification to know where to put the paint, right? And does that piece of the supply chain have the right IT security in place, right? It's two guys in a garage painting something blue. That feels to me, if I were trying to do industrial espionage, that might be an easier place to rip off some IP than Lockheed Martin or something.
Well, this has been great to learn about essentially how manufacturing is going to respond, or how they can respond within disruptive times, and what role Paperless Parts plays in between the role of the designer and the manufacturer. And are we calling a job shop similar to a designer?
Well, they're in between. You have these companies designing these new products, and then you have job shops trying to figure out how to produce them. And there's a ton of engineering and know-how that gets applied at the job shop level. But they're also they're not designing the airplane.
Yeah, right.
But they are figuring out how to make it.
Well, this is great. I thought that when we started, this would be a great way to understand about disruption within the manufacturing space, because we've taken so much manufacturing back into the United States from overseas, and just as a result of the corona, we're going to have even more because of the disruption in our supply chains. But I love how you guys are playing in that space that helps with the agility and helps with the collaboration and the speed to market, because I think that's the ultimate win that the consumer wants on that side, on the consumer side, but everybody within that supply chain wants that speed, because it's the requirement of the day and age that we live in.
Absolutely. It's what's expected now, and it's what we need moving forward for sure. Just the ability to move really quickly and manufacture smarter.
Is there anything that you wanted me to ask, Scott, as we wrap up, that you were hoping that I'd get to, either related to the current issues or any points that I missed asking you about?
Yeah, I'm just saying we talked about security. That was good, I think. I had some stories about different companies doing different things in Industry 4.0, but I think we went in a at least as interesting direction.
Well, I would be interested, in doing a version 2 with you, that I think as we go, and as manufacturing is really impacted and needing, especially in this case that we're talking about, resilient supply chains and the ability to respond quickly to a crisis, whether that's a crisis caused by a market condition or a crisis caused by this biological impact we have with the corona. I think it really, this business continuity planning, this BCP planning, is something that we hadn't really thought about as an industry. I know in my industry, in the IT security industry, the last time this happened was 9/11. And if you are sub 35 years old, you were living with your parents when that happened, and you really haven't had a chance to see the type of continuity planning that's needed. And I think there's an interesting play for you guys in the continuity world of being able to have this continuous iteration in the midst of both economic disruption caused by just 3D printing coming online versus traditional manufacturing, but then also this pandemic. So it's an interesting.
Well, and that, to speak of people want to reshore stuff, people are thinking, okay, well, maybe I don't want my supply chain as global as it's been, or maybe I at least want a secondary source of supply. But all this stuff, if there's a point to be made, is that the high-tech stuff we're making today is hard to manufacture. It's not, it's not as simple as, we're not sewing masks, right? It's not like I can just train someone up quickly to create this commoditized thing. If that were as simple as it would be really easy to stand up secondary sources. The challenge is to make something efficiently and at the right cost and quickly enough. you need that machinery and the technology in place. And that's what's now happening. People are realizing, okay, I can't count on a single source for this part, this component in this thing I make. But to stand up a second source of supply, that's where you need to have this iteration and this fast moving communication to be able to get someone tooled up.
Well, Scott, it's been a pleasure. I've enjoyed the conversation. It's it's for my audience, it's going to be different to hear a different education about something that we hear. We must get the masks, we must get the ventilators, we must get the stuff out into the market. And we've always wanted to go speed, but interesting to have a speed of iteration of like the innovation game. But then all of a sudden, we not only need to innovate. This is like World War II. We need to save a lot of lives and respond super fast.
It's pretty wild.
Explore that it's not just about putting a mask out there. You got to look at the machine parts, and you got to figure those details out along the way that gets you to the end product, so you can go quickly.
Absolutely.